I'm here at the Things conference from the Things Industries with Cecile Joannin, and she's with SAFT, the battery company. I always make fun that SAFT is the German word for, actually you made that joke earlier.
Yeah.
But what does it stand for again?
Oh, it stands for the Society of Accumulation for Fixed and Traction Batteries, basically. It's an old French company, 100-year-old, and it's always been busy with batteries so far.
Well, you know, living in Germany, I always think of the German word for electricity, which comes out nicely with the battery company.
That's what our German customers always do, yeah.
Well, you know, one of the things about the issue is, for all of the electronics we have, nothing happens until you move the electrons around, and you need power.
Yeah, exactly. Power, electricity, and it's actually the life of the IoT device, so it's a critical part. The battery is a critical component, and sometimes it's overlooked. People are sometimes overconfident on the skills and knowledge they have about batteries, but after, sometimes they feel like they don't have much information about batteries, actually. And this is why SAFT is always trying to support prospects and IoT developers and teach them how to find the right information and even making lifetime calculation for them.
Well, you know, when you think about energy storage, it's been a moving target from the beginning. Lead acid, tin lead, nickel cadmium, nickel metal hydride, lithium. Where do you see it going? What do you see the migration pursuing?
I think the technology SAFT is using today, the primary lithium batteries that are non-rechargeable batteries, are pretty much, they have a very big energy density compared to what we know about lithium-ion. For example, the tonyl chloride technology has an energy density of 700 watt-hour per kilogram, so it's huge. And I see the progress on these technologies more on the anticipation of the end of life. I mean, what the customer want today, they want to be reassured about the fact that they will have no failure on the field. So what we are trying to do at SAFT is first to commit on a lifetime for their device, and given the conditions of usage they have. And second, we want to also make them sure that the device if the device will fail on the field, they will know in advance so that they are able to make predictive maintenance, for example.
So now that's live diagnostics then, so you've got chips inside the cells and all. Does that then also contribute to safety monitoring?
Exactly. So this is something that is done already on lithium-ion technology, so rechargeable cells. But our goal today and in the future, in the next months or years, is to manage this for non-rechargeable cells. And given their behavior and the way these cells are aging, it's very tricky. And so this is what we are putting efforts today into.
I would like to sound more sophisticated, but I didn't realize that there was such a big market for non-rechargeable cells. Why is that?
Actually, when you have to deploy millions, or let's be reasonable, thousands of sensors over a big area, you don't necessarily have a plug to recharge your battery. So some people use solar. But if you don't have sun, then it could be tricky also to have your device powered. So most of people have, in this case, a backup with a rechargeable battery. But actually, it's much easier to have a non-rechargeable battery, which makes your system fully autonomous. And even for a remote sensor, if you have a lifetime of 10 years, why would you bother with taking the rechargeable battery? Because you have less electronics, and still you have a 10-year lifetime, which is pretty much the lifetime required for your sensor. So non-rechargeable batteries actually are taking the leads on these kind of applications.
Because I must admit, I used to think of lithium thionyl chloride in like remote metering situations, but you make an excellent point that all of these remote sensors, they don't all work on energy harvesting.
Yeah, and it's not, to me, energy harvesting could be very interesting as well, but it's not, contradictory to the use of a battery, because if you need a reliable system, if your data is critical, if you can't have someone going to the field and change your system, then it's always good to have a backup with a battery. So actually, energy harvesting and battery are complementary and are both participating to the reliability of your system. And I think this is today what the IoT market is trying to prove. It's that these systems are reliable and that they are bringing value to the customers. And this is why it's very important that not only the data and not only the computing part is taken care of, the security, we hear a lot about cyber security for IoT systems, but also that your hardware is good and strong enough to bring enough value to your customer for him to deploy then more widely these solutions.
Very cool. Now, when I think of those kinds of things, one of the things that was interesting is in our pre-brief you mentioned an anecdote about the batteries. I'd like you to repeat again about the spacecraft.
Oh yeah, with SAFT is actually one of the manufacturers that is delivering, producing batteries for launchers and satellites. And yes, sometimes you have these systems, they only rely on battery, and in space, of course, you cannot allow any problem with the battery because everything runs on battery. So yeah, we had the example of the Rosetta project, which actually the rover...
The Comet Chaser, yeah.
The rover was landing in a place on the comet that was not fully lighted by the sun. So the rover was able to go into the more, let's say, to the place it has to be landed actually, thanks to the battery that was in the launcher for 10 years. So the battery has waited 10 years into the launcher to be activated, and they did manage it. So we were very, very happy and proud about this.
Well, I can imagine, a backup that works is a perfect legacy of performance, right?
We have also the example of the Boeing that landed on the Hudson River. Many years ago, there was a movie with Tom Hanks about this episode, yes. And actually the pilot managed to land the aircraft thanks to the battery because there was no electrical system running and only the battery was working.
Well, I think that's a great note to end on how fantastic batteries are. And I want to thank you, Cecile, for taking the time, at this busy show to be with us today. I really appreciate it.
Thank you, Alex.
And the website is SAFT.com?
Yeah, SAFTbatteries.com. Yeah.
SAFTbatteries.com.
Yeah,
excellent.
Excellent.
Thanks a lot.
Thank you very much.